can I factor more? So are we done? Is there more we can do? Can we group it? Can we take out a greatest common factor? Do you see a nice easy quadratic we can factor? All right, we have 4 terms. I see that they are all even terms. So I actually see a greatest common factor of 2 that I can reduce out of all those terms. So I can take this as x plus 1/2, reduce out or factor out that 2, and this becomes 5x cubed minus 16. Oh, I'm taking a 2 out. So minus 8x squared minus 14x plus 12. You should always see this pattern. You see that 1/2 and that 2? And if they multiply together, they'd become a 1. You'll always see that pattern. If you factor out a fraction, you can also factor out a greatest common factor of whatever that denominator is. So that pattern will always happen. Right, can we factor it anymore? So I see 4 terms. I could try to group them, but that gets kind of messy sometimes, especially when I look at the negative 14x plus 12. And if I try to factor that side out, then they don't really have, I mean, they have a 2, but it doesn't reduce very far. And the 5x cubed minus 8x squared, even if I take out an x squared, I'm going to have a 5 that I'm going to have to deal with. All right, so grouping is probably not the best on that. But I do know that I can do all 4 steps over again. Yay, I know you're really excited about that. Okay, so see what we have left? We are going to repeat our 4 steps with that cubic polynomial that we're given. So I'm going to call this step 1B because we're doing it again. All right, we never want to lose track of what we already have, the x plus 1/2 and the 2, so make sure you keep those at all times and you just start factoring the other pieces. It's easy to lose track of those, so be careful. All right, so let's make our list of possible rational roots. All right, so this list should be all the same numbers from our first group, but much smaller, right? Because we're reducing all of this down. So plus or minus P over Q, which represents the factors of the constant, which is still, let's see, we got a 12 there. All right, so that's our constant. All right, and then their factors of your lead coefficient, which is right here, R5, our lead coefficient. So plus or minus, all right, so 12. So I got 1, 2, 3, 4, 6, 12. All right, and our lead coefficient is 5. Oh, that's nice. I only have to deal with 1 and 5 now as my possible denominators. All right, so they're taken from that top list, but we're only using what we have left. So these should look really similar. Actually, they should look exactly the same, but some of them should be missing because we're only using the 1 and 5 as denominator. So plus or minus 1, 2, 3, 4, 6, 12. So it's all divided by 1. And then our 1/5, 2 over 5, 3 over 5, 4 over 5, 6 over 5, and 12 over 5. All right, we don't have anything that we can cross off. There's no duplicates because the set's much smaller now. And we already tried +1 and -1. If it didn't work before, it is not going to work now. So I'll just tell you that right now. Okay, so we're going to fast forward, and we're going to pretend that I checked 1/5 and they did not work. And that I checked 2s and they didn't work. And I checked the 2/5 and they didn't work. And then I got frustrated, which is just like what you will do. And you're going to take a breath. You're going to keep going. And I checked my 3s, and guess what? They didn't work either. So I checked my 3/5, and one of them worked. I'm going to prove it to you. All right, so 3/5, I need a positive and a negative. All right, so I'm going to do +3/5. And again, it's either going to go pretty or it's going to go wonky, and I'm just going to stop right there. And -3/5. Okay, so I'm looking at that 5x cubed minus 8x squared minus 14x plus 12. So I'm working with that. So my coefficients are 5, -8, -14, +12. So 5, -8, -14, +12. Okay, so you do have to go back into your fraction zone and think about how to multiply fractions. So in a fraction, your numerator, that top number, multiplies, and your denominator, the bottom one, divides. So I'm going to show you. Bring down my 5. If I multiply 3/5 times 5, then I have 15, because 3 times 5 is 15, divided by 5. What is 15 divided by 5? 3. Okay? So -8 and 3. So that gives me -5. 3 times -5 is -15. Divided by 5 is -3. Oh man, -17. Okay. -17. So I need 3 times -17 plus 5, right? Did I do that right? 3 times 5, 15. All right. -5. All right. Yep. Here we go. Okay, so 3 times -17. Okay, so 30. Right, so 3 times 10 is 30. 3 times 7 is 21. So -51 over 5. Hold on, I feel like I did something wonky there. Oh ho ho. Okay, I did it up here. Sorry. You probably saw it and you're like, oh, that's going to catch up to her sooner or later. So this piece up here, 34 divided by 2 is a 17. So this and this are 17. Sorry. Okay. Done. Fixed. See, I make mistakes too. Okay, so that's a 17. So -17 minus 3 is -20. 3 times -20 is -60. Divided by 5 is -12. See, that's how I knew I went wrong, because I knew this should have become a 0. So be careful of that. I'm going to go, woo, 0. And then I cry a little bit because I just tried so many factors and it finally worked. And then guess what? Don't even use that one. Once you find a 0, you stop at that point. Don't do more work than you have to. And obviously check your work so you don't make simple mistakes like I did. Even if you did, then you would have kept going and you would have found another factor somewhere. Okay, so step 2. Step 2b, because we're doing this for a second time. All right, so we need to rewrite in factored form. Okay, super duper important. Don't forget other factors. So coming up here and looking at these factors that we've already divided out, don't forget those. So we already have our x plus 1/2, and we already have a 2. So what did we just get from this? Okay, we used that 3/5. So since x equals 3/5, it makes a factor of x minus 3/5. And then since we had our synthetic quotient of 5, -5, -20, that becomes, let's see, I started with an x cubed, so this is 5x squared minus 5x minus 20. All right, so those are the new ones we just got. X minus 3/5, 5x squared minus 5x minus 20. Okay. Oh, I kind of wrote that silly too. That was step 3. Testing it here was step 2. Was our test. I kind of did that all together in one thing. Okay, so that brings us to step 4. So step 4, you ask yourself a question. Can I factor more? Well, you have a quadratic, so the answer, unfortunately, is yes. Yes, you can. First thing, there's a greatest common factor here of 5. So I have x plus 1/2 times 2 times x minus 3/5 times 5. And then I'm going to reduce those by 5. So times x squared minus x minus 4. Can I factor more? I sure can, because I still have a quadratic here. All right, so is there anything that adds to -1 and multiplies to -4? Unfortunately, the answer is no. So you are forced to use the quadratic formula. That says formula, by the way. So I'm going to show you your final x's. Right, so from this one here, we have x equals -1/2. From this one here, we have an x of 3/5. And then from our quadratic, if you were to put that into your quadratic formula, you would get x equals 1 plus root 17 over 2, and x equals 1 minus root 17 over 2. It's a lot of work.